Today I'm going to do the Theorem of Pythagoras, which is for grade 8. Now, let's move on. I want to repeat again. What is a theorem? I am going to repeat this for you, friends. A theorem can be defined as a rule, principle, or a statement that can be proved to be true. Now, moving on. Theorem of Pythagoras. Now we know that the theorem is a statement that can be proved to be true in simpler terms. The theorem of Pythagoras states that in a right-angled triangle, please get that now, the square of the hypotenuse is equal to the sum of the squares of the other sides. Now, moving on. Let us now take the diagram. Now, in a diagram form, what we have just said is the square of the hypotenuse. That side is the hypotenuse, which is opposite the 90 degrees angle, is the sum of the squares of the other two sides. Now, if you are looking at that, it means that all those little squares or small squares there must actually be equal to the total of these two together. Now, I want to count these ones first for you to prove that the theorem is correct. Let's go 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, we have 25 little squares here. Now, when we count these together with these, we must get 25. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That means this theorem is spot on. Now, let us look at it in a mathematical form. If the hypotenuse is said to be small c, and this side is small a, and that one is small b, that means c squared is actually equal to a squared plus b squared. That is the theorem of Pythagoras that you will be applying if you are given a right-angled triangle, a triangle with one angle which is equal to 90 degrees. Now, let us look at the calculations. The diagram shows triangle PQS, triangle PQS there. Now, with PQ equals to 2 root 77, QS, which is equals to 6 root 3, it is not that, I'm sorry about that, and PQ is equals to 10 root of 2. Now, what do they want us to do? Let us look at that. They say determine if triangle PQS is a right-angled triangle. Now, for it to be a right-angled triangle, the square of this side must be equal to the sum of the squares of those other two sides. Let us determine that. First of all, I'm saying PS squared, which is that side, is actually equal to 2 root 77 all squared. Now, 2 root 77 all squared is equal to 308. Remember, I'm not calculating this side. I am proving that this triangle obeys the theorem of Pythagoras. What is next now? I must prove that this side plus that side, when they are squared, each one of them, they are equal to 308. Let's see that. Now I'm saying QS squared plus PQ squared, which is equals to QS is 6 root of 3 all squared there, and PQ is 10 root of 2 all squared. Now, let's simplify that. When you simplify 6 root 3 all squared, you get 108. When you simplify 10 root of 2 all squared, you get 200. And 108 plus 200 is actually 308. Can you see that PS squared, which is actually equals to the sum of the squares of the other two sides? Now, that is why I'm saying the left-hand side is equals to the right-hand side. Now, moving on, that means triangle PQS is actually a right-angled triangle. Why? Because it obeys the theorem of Pythagoras. Now, our next question says, what type of an angle is angle Q? What type of an angle is that? Now, because this triangle is obeying the theorem of Pythagoras, it means that angle Q is equals to angle Q is equals to 90 degrees, and it is a right angle. Moving on. Now, study the sketch and calculate. There's our sketch. Do you see in our sketch, we've got two triangles, triangle ABC, which is a right angle triangle, and triangle CDB, which is a right angle triangle. Now we can use the theorem of Pythagoras in this one freely so, because we know that those two are right-angled triangles. Let's do that. There we go. The length of BC now is supposed to be calculated. We want to calculate BC. Look at the triangle that has got most information, triangle ABC. We know AC, we know AB. Now it means to calculate this side, I'm going to use triangle ABC. Let's do that. Now, AC squared, which is the hypotenuse, is equals to BC squared plus AB squared. That is the theorem of Pythagoras. Moving on, we substitute. AC squared is 25 centimeters, 25 squared plus BC, we are looking for plus AB squared. Now, when we simplify this, let's simplify that. When we simplify it, 25 squared is 625 and 20 squared is 200. It is 400. I'm sorry about that. It is not 200. It is 400. I'm sorry about that. Now, moving on. 625 minus 200. I would work with 200. In this case is 225. Fine. Now, BC squared under the square root sign is equal to 225, square root of 225, which is 15 centimeters. Moving on, we now know that BC is 15 centimeters. We substitute that there. Now, do you see that in this triangle, BCD, now we've got how many things? Two things. It means we can use them to calculate that now. The length of BD. Calculating the length of BD, we use the theorem of Pythagoras. There we go. Now, using the theorem of Pythagoras in this case, folks, be very, very careful. When we use the theorem of Pythagoras, it is only when we have a right-angled triangle, not in any other triangle, okay? Because I'm not looking for the hypotenuse, I now manipulate. BD, I make BD the subject of the formula, which is equal to BC squared minus CD squared. I've got that. Let us substitute. Now, when we substitute, there we go, 15 squared minus 12 squared. Moving on, 15 squared is 225 minus 12 squared, which is 144. 225 minus 144 now gives us 81. We find the square root of both sides. Finding the square root of both sides, BD is equals to 9 centimeters. That is how wonderful the theorem of Pythagoras is in this case. Now, let's move on to the next question. We are now calculating in a practical situation, folks. The theorem of Pythagoras can be used in real life. Remember that. In this case, a small boat sails on the Vaal River at a given time. The slant distance is that one, which in this case is going to be the hypotenuse. To the boat is 19,2 meters. The slant distance from there to there is 19,2 centimeters, sorry. And the boat is 9,2 meters from the side of the river. Here's the side of the river, there's the boat. It is 9,2 meters from the side of the river. Calculate the perpendicular distance. There's your perpendicular distance. Now, let us calculate the perpendicular distance AB. Because we have got the right-angled triangle, that means again we are going to apply the theorem of Pythagoras. Now, BC squared, our C is where the boat is. BC squared, which is the hypotenuse, is equal to E squared, which is the distance from the boat to the shore, plus AB squared. All right, now substituting 19,2, which is the slant distance all squared, is equal to 9,2 all squared. Okay? Plus AB squared. Now, when we simplify these, this is what we get. 19,2 all squared is 368.64 minus 9.2 squared is 84.64. Remember, now you have to group them by taking the 9.2 squared into that side, and it changes from positive to negative. That would give us 8 squared. All right. Now, when we subtract the 2, we get 284, but that is AB squared, not A. Now, to determine AB, we have to do what? Take the square roots of both sides. The square root of AB squared is AB. The square root of 284 is 16,9 meters. That means from here to there, it is actually 16,9 meters. Okay? Moving on. Oh, now, there's your QR code, folks, for practice questions. And if you don't have facilities to scan the QR code, there's your link down there. Please practice this theorem because it is always in the exam. Thank you very much.